Welcome to Writing and Graphing Inequalities. Today we're going to talk about how to graph an inequality, write inequalities from a graph, how to graph inequalities from word problems, and how to write inequalities from word problems. So first, let's talk about what an inequality is. An inequality is a mathematical sentence that contains these symbols. So we're looking at the symbols up here with the less than, greater than, less than or equal to, and greater than or equal to. So we're looking at these symbols up here. And we use those in a number sentence so you can read it as a sentence. So if I were to say 7 is greater than 6, mathematically as an inequality that would look like this. And then what we're going to talk about mostly is when we have a variable, so you have x is less than or equal to 10. Both of these are examples of inequalities. In this case, x is a variable and can be replaced by any number, but only certain numbers are going to make it true. And that's where we go into solution of an inequality. The solution of an inequality is any value that makes the inequality true. So if I have x is greater than or equal to 10, or I'm sorry, x is less than or equal to 10, I know that I can put in numbers like 9, that makes it true, and 0, even -3, or 4.5, or 2/3. So all of these are examples of solutions of the inequality. Now you'll notice that they have a lot of options and there's a lot of numbers that we could plug in for x that would fit this inequality and make it true. So this is why we talk about graphing inequalities, because there is really no way to write all the numbers. There is no way to write all of the numbers that would solve some inequalities. So some inequalities have an extended part here where you might see like 9, so it has to be between 9 and 10. But even still, even though that limits the amount that you can use, we know that numbers go on forever in both directions and even with decimals. So we look at graphing solutions instead of trying to list all of them. Okay, and then this kind of goes along with vocabulary, but it does not need to go in your vocabulary notebook, okay, unless you want to put it in there, but this should go in your notes. So we have the tipped L, which is the less than sign. And then we have the opposite sign, which is the greater than sign. So you can take your left hand and make an L and tip it, and if it matches this sign, then that's the less than sign. Now here you'll notice we have the less than sign with half of an equal sign. That helps you know that it is less than or equal to. It's not completely equal to because it can also be smaller than the number or the number itself. Greater than or equal to, again, the same symbol with half of an equal sign. And then not equal to. And not equal to is pretty self-explanatory. You put it in there, and if it's not that number, it's not equal to it. Right, so let's go through and let's find some inequalities to work with here and look at those solutions. So here I have x is greater than or equal to 9. So we have to think of solutions for x. Well, if I put in 8, is 8 greater than or equal to 9? Since the answer is no, 8 is not a solution to this inequality. 9, is that greater than or equal to 9? It is equal to, so 9 is a solution. And we could do 10, we can do 100, we can do 12 and 2/3, we can do 1,346,000. Okay, all of these numbers are solutions to this inequality. And looking at it, you're looking at, okay, we went from 10 to 100 to a million. Well, like I said before, there's infinitely many solutions. So as long as the number is larger than 9, so as long as whatever you plug in here fits this sentence, it works as a solution. So here we have 4 is less than m. So we look at 4. Well, there's no equal to sign here. So since it's not there, we can't use 4 as a solution because it cannot be equal to 4. It has to be less than 4. So could I use 3 and 9/10? Absolutely, because that is less than 4. I could also use -1. I could also use 2/3. Okay, so it's all kinds of different numbers that'll fit this and make this true. Here we have b is less than or equal to -2. So again, negative 2 would work. Now, negative 1. Negative 1 won't work because remember, with a negative number, okay, so here's 0, negative 1, negative 2. Negative 2 is further away from 0. So as you're going down this scale, your numbers are getting smaller. So what that means is if you go up from negative 2, that means negative 1 is larger than negative 2. So it will not work as a solution. So we're going to go ahead and erase that. That is not a solution. Okay, but I do know that negative 3 is, negative 4 and 5/6, negative 12. So all I know is all of my answers will have that common thing of being negative. And here G is not equal to 3. Well, we know that 3 is not an option because it cannot be equal to 3. So kick that out. But now that is the only limitation that it has. So any number that is not 3 is going to fit this, whether it's negative, 0, or positive, it's going to fit this. So again, we have infinitely many solutions. There's no way to write all these solutions. So 2/3 is not equal to 3. 12.5 is not equal to 3. So again, this is why we look at graphing inequalities. So you can see on a number line all of the possible answers, and you don't see all the possible answers, but you can look at it and say, okay, well, anything that fits on this line or would fit on this line would be a solution. All right, so let's take a look at what I mean by that. So here you have a closed dot and an open dot. The closed dot means that it can include the numbers. So these are your greater than and or equal to, and your less than or equal to symbols. So the equal to tells you that it should be filled in. That means it can include the number, that the number could be part of the solution. Can't include would be your less than and your greater than. Okay. And then it could also be your not equal to. Okay, so think about when we graph numbers on the number line. If I said to plot 5 on the number line, we would put a closed dot right here because it includes the number and it's 5 that we're looking for. So keeping that in mind, let's go ahead and look at how we would plot these inequalities. So we have x is greater than 9. Since it's greater than 9 but not equal to, it can't include it, so we use an open dot. And make sure it's very evident that it's an open dot. And it has to be on the number line, not above, not below, on the number line. So we have an open dot, and I'm actually going to make this into a purple line so we can see it a little bit better on the number line. And now I know that it has to be greater than 9. So numbers that are greater than 9 mean bigger, so it means we're going to the right on our number line. Okay, and actually let me try to make this a little bit bigger. Okay, so now what this means is any number that covers this, so I'm actually going to draw it so you can see it. Make it a little bit thicker. Okay, so we just draw a line and then we put an arrow on it to show that it keeps going, because we'll learn about inequalities and graphs where you have circles on both sides. But here it can keep going because it can be any number greater than 9. So this tells you that it can't include the 9, but it can be anything that is bigger than 9. Okay, for the next one we have x is greater than or equal to 9. So again, the greater than or equal to means that it's going to be to the right, because greater than means it goes to the right, but this time it can actually include the 9. Since it can include the 9, we use a closed dot to say 9 can be part of our solution set. And then now I draw my arrow going to the right because I want all numbers greater than 9. And I would just go to the end of the arrow and then make the arrow that color. So here I have x is less than -4. So again, there's no equal sign, so I use an open dot. on the -4, and it has to be less than -4. Now you know on a number line when you go less than, it goes to the left. Still the same thing with the negative. So even though -6, it seems awkward that it's less than -4, it is, because remember, somebody who owes $6 has less than somebody who owes $4. Right? And then again, we have x is less than or equal to -4. So it looks the same in the direction and the circle, but this case the circle is colored in. And it's on the 4, or on the -4, and then I have my arrow pointing to the left because it's less than. So this will kind of help you out. Less than means it's pointing left. Okay, I know the symbol is greater than, but it's saying that x is less than 4. And actually the symbol is less than. My goodness. See, even we get tripped up sometimes. Okay, so now we're going to go in reverse. So now we're going to make inequalities from the graph. So based off of this, I know that it should be an equal to sign because it does include the 8 because it's filled in. Now here it's -8. So I'm going to wait to put the -8 in until I decide my direction of my arrow. My arrow is pointing to the right, so since it's pointing to the right, it means my numbers are bigger or greater than the -8. So I'm going to use the greater than symbol, and I know that x, whatever it is, has to be greater than -8. And it is important, it does matter the direction, the symbol, everything, because this is greater than. So we don't want to put -8 is less than x because that's not what we're working with. We're working with numbers that are bigger than 8. So you have to think of which direction is it pointing. If it's pointing to the right, you should be using the greater than symbol and then making your inequality work that way. So here I have an open dot on the 5, so there's no equal sign on the bottom, and it's pointing to the left, so I know that it is the less than symbol. So I know that x has to be less than 5. Again, it's pointing to the right, so here left means less than. Here it's pointing to the right, so it's got to be the greater than symbol. It's open, so there's no sign underneath. So x has to be greater than -12. Pointing to the left, so it's less than. And it's a closed dot, so it has to have the line underneath. So x is less than or equal to 18. Okay, so the direction tells you which symbol to use. So if it's pointing to the right, you use your greater than, and if it's pointing to the left, you use your less than. And then if it's a closed dot, you use the equal sign, and if it's an open dot, you don't. Okay, so it includes it or it doesn't. Okay, now we're going to look at word problems. So from word problems, so to pass your quiz, you have to get a 70% or higher. So the question becomes, can you get a 70%? If the answer is yes, then you know that it has to be a greater than, less than, or equal. So it's a greater than or equal to or a less than or equal to problem, which also means you have to have a closed dot. So let's work one at a time here. It's easier to write the inequality and then graph it instead of really kind of working your way through the problem twice. So to pass it, you have to get a 70% or higher. So higher tells me that it has to be greater than 70. So your score of x has to be greater than 70%. So to plot that, I'm going to put 70 here, and we'll go 80 here, 90, so I'm skipping 2 every time. And now I don't have to put all my numbers on here, but I do know that it has to include 70, so I have a closed dot, and it has to be greater than 70. So even if I don't do the whole line, as long as I have this arrow here to show me that it goes on forever in that direction, I'm good. So I can get any score. I can get 200%, and it means I passed my test. Okay, to stay home from school, the temperature has to be at least -10 or lower without wind chill. Okay, so at least means that it can include the -10. So it's saying if it's -10, you can stay home. So since it includes it, you know that you have to have your equal sign. And then at least, so the least implies that it has to be less than the -10. And it tells us here or lower. So even if we took this out, if we said to stay home from school, the temperature has to be at least -10 degrees without wind chill, even if we took this out, it would mean the same thing. Okay, so I know it has to be less than or equal to -10. So T, my temperature, has to be less than or equal to -10. Okay, to go swimming, it has to be more than 70 degrees outside. So if it's 70 degrees, can you go swimming? Well, it says more than 70 degrees. So in this case, you would have an open dot, and you would not have an equal sign. So here we go. So we have 70 degrees, so it has to be more than, so it has to be the greater than symbol. So the temperature has to be greater than 70 degrees. Okay, and let's finish these, and then we'll go back and graph them all. So to get your driver's license, you have to be 16 years old or older. So that tells me, or tells me that I can be 16, so it can be equal to, but it either has to be 16 or greater, so it's the greater than or equal to symbol. So your age has to be greater than or equal to 16. Okay, so you have to look for these keywords. So older would be your key that it needs to be greater. The or tells you that it could also be equal. So here we have -10, so I'm going to put -10 here. 9, 8, 7, 6, 5, -5 here. 4, 3, 2, 1, 0 here. All right, and so now it has to be less than or equal to -10. So it can be -10 degrees, but it has to be colder than that to stay home. So it has to be -10 degrees or colder to stay home. And then here, so I have 70, 72, 74, 76, 78, 80. So notice I'm writing it all different ways just so we get practice filling out a number line. As long as you stay consistent, it doesn't matter. 2, 4, 6, 8, 10. So here's 90. 2, 4, 6, 8, 10. So here's 100. Okay, so it has to be more than 70 degrees. So it's an open dot because it can't be, you can't swim if it's 70 degrees. It has to be more than 70 degrees. And then more than implies greater than, so my arrow points to the right. And here your age has to be 16, so I'm going to do 10, 11, 12, 13, 14, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so now here I don't have the 16 written, but I know that this is 16. And since it's greater than or equal to, I have a closed dot because I can be 16 and get my license. But if I'm not 16, I have to be older than that to go in and get my license. I cannot be younger, so the age has to be greater than or equal to 16. All right, so here are some problems that you have to work on your own. So I want you to create an inequality from each of these. And then I also want you to create an inequality from the word problems and then create your graph. As always, if you have any questions, be sure to email me or write them down so we can go over them in class.